Hello. So here I got connected for the third episode of this GCP Essential Cloud Infrastructure Foundation. So let's go immediately to what we left last time. Okay, so I'm completing my cloud architect learning path. Behind me, there's Domingo sleeping and having a nightmare. Okay, let's see here. In the leaderboard, I'm 70th. In the gold league, we have 5 days. It's a lot of time. So resume the course.
Let's use what we have learned.
Okay, and let's see. You can hear all my sound. Yeah, so good. Let's put a bit of focus here. Yeah. So to recap, in this section, we are doing virtual networks, virtual private cloud, project network, subnetworks, IP addresses, assignation of IP addresses, internal and external, mapping of addresses, routes and firewall rules, and we had already virtual private cloud networking lab in which we created different virtual private clouds, different virtual machine inside all of these virtual private clouds, and then we use different protocols to communicate with the other machines via internal and external IP in different scenarios. Therefore, now we will start using some network designs with this. What I mean is that, for example, in the scenario we built, we had machines in a subnetwork in a US region and then in a Asian region. Both these subnetwork were part of the same virtual private cloud. And then we had another virtual private cloud, which had only one region. Therefore, in that case, it was just one subnetwork. And what was happening is that without using any other mechanism, we had the possibility to use only firewall rules to determine which machine could speak to the others. And when we wanted to go to another virtual private cloud, so to reach machines across different virtual private clouds, we had only the external IP as an option. Therefore, if we want to not go to not communicate publicly, we need to use a network design. So we will see virtual private, VPC peering, and VPNs. Let's go.
Let's use what we have learned so far and look at common network designs. Now, common is a fairly relative term. While I could spend all day talking about network designs, I have picked a handful of designs that best relate to this module. Let's start by looking at availability.
This person has a really
If your application needs increased availability, you can place two virtual machines into multiple zones, but within the same subnetwork as shown on this slide. Using a single subnetwork allows you to create a firewall rule against the subnetwork, in this case 10.2.0.0/16. Therefore, by allocating VMs on a single subnet to separate zones, you get improved availability without additional security complexity. A regional managed instance group contains instances from multiple zones across the same region, which provides increased availability. Next, let's look at globalization. In the previous design, we place resources in different zones in a single region, which provides isolation from many types of infrastructure, hardware, and software failures. Putting resources in different regions, as shown on this slide, provides an even higher degree of failure independence. This allows you to design robust systems with resources spread across different failure domains. When using a global load balancer like the HTTP load balancer, you can route traffic to the region that is closest to the user. This can result in better latency for users and lower network traffic costs for your project. We'll explore both managed instance groups and load balancers later in this course series. Now, as a general security best practice, I recommend only assigning internal IP addresses to your VM instances whenever possible. CloudNet is Google's managed network address translation service. It lets you provision your application instances without public IP addresses, while also allowing them to access the internet in a controlled and efficient manner. This means your private instances can access the internet for updates, patching, configuration management, and more. In this diagram, CloudNet enables two private instances to access an update server on the internet, which is referred to as outbound net. However, CloudNet does not implement inbound net. In other words, hosts outside your VPC network cannot directly access any of the private instances behind the CloudNet gateway. This helps you keep your VPC networks isolated and secure. Similarly, you should enable private Google access to allow VM instances that only have internal IP addresses to reach the external IP addresses of Google APIs and services. For example, if your private VM instance needs to access a cloud storage bucket, you need to enable private Google access. You enable private Google access on a subnet by subnet basis. As you can see in this diagram, subnet A has private Google access enabled and subnet B has it disabled. This allows VM A1 to access Google APIs and services even though it has no external IP address. Private Google access has no effect on instances that have external IP addresses. That's why VMs A2 and B2 can access Google APIs and services. The only VM that can't access those APIs and services is VM B1. This VM has no public IP address, and it is in a subnet where Google private access is disabled.
Okay.
And better latency for users and lower network traffic costs for your project. Google's managed network address translation service. It lets you provision.
So first of all, GCP NAT. This. So CloudNet provides network address translation for outbound traffic to the internet, virtual private cloud networks, on-premises networks, and the other cloud providers. So it's only in one direction, outward. CloudNet NAT provides NAT for the following Google Cloud resources: Compute Engine, Kubernetes, Cloud Run functions, App Engine, regional internet network, and endpoint groups. CloudNet supports address translation for established inbound response packet only. It doesn't allow unsolicited inbound connections. So you cannot use it as a load balancer, basically. Okay. Private NAT. Okay. So here we have some benefits. You can reduce the need for individual VMs to each have external IP addresses. Can access the destination on the internet. For example, you might need to internet to download a place or complete provisioning. Okay. Okay. Great. And then we had these other details.
Provision your application instances in a controlled and efficient patching, configuration management, and more. In this diagram, CloudNet enables two private instances as outbound net. However, CloudNet does not implement inbound net. In other words, hosts outside your VPC network cannot directly access any of the private instances behind the CloudNet gateway. This helps you keep your VPC networks isolated. Similarly, you should enable private Google access to allow VM.
Okay. So it's saying private Google access. GCP private Google access. This is not clear for me. Private Google access. VM instances that only have internal IP addresses, no external IP addresses, can use private Google access. They can reach the external IP addresses of Google APIs and services. The source IP address of the packet can be the primary internal IP address of the network interface, or an address in an alias IP range that is assigned to the interface. If you disable private Google access, the VM instances can no longer reach Google APIs and services. They can only send traffic within the VPC network. private Google access has no effect on instances that have external IP addresses. Instances with external IP addresses can access the internet according to the internet access requirements. They don't need any special configuration to send requests to the external IP addresses of Google APIs on services. You enable private Google access on a subnet by subnet basis. Okay. It's a setting for subnets in a VPC network. To enable a subnet for private Google access and to view the requirements, see configure private Google access, blah, blah, blah. Okay, let me see, where do you configure this? I think when you go to the subnet, you can define these aspects. Let's see, network requirements, summary, network configuration, private configuration. Okay, now I understood what it was saying. Okay, we can continue.
Let's
Now
apply
we
what we
have the
just covered.
lab.
In this lab, you implement private Google access and CloudNet for a VM instance that doesn't have an external IP address. Then you verify access to public IP addresses of Google APIs and services and other connections to the internet.
Great, let's go. So it looks like it will be a short one, even if we have 1 hour and 20. I hope to complete this, let's say, in half an hour. So we have 5 tasks, including the review. Let's start. So let me clean my notepad. Okay. Let's open this in incognito. Okay. Password. Let's go. Okay. Let me share this second. Okay, you already have it back there. Now, let's see the first task. Create the VM instance. Create a VPC network with some firewall rules and a VM instance that has no external IP address and connect to the instance using an IAP tunnel. What the fuck is the IAP tunnel? I already encountered it, but never studied it. Identity-aware proxy. This page explains how you can use identity-aware proxy TCP forwarding to enable administrative access to VM instances that do not have external IP addresses or do not permit direct access over the internet. IAP TCP forwarding allows you to establish an encrypted tunnel over which you can forward SSH, RDP, and other traffic to VM instances. AAP TCP forwarding also provides you fine-grained control over which users are allowed to establish tunnels and which VM instances users are allowed to connect to. Okay. So in the videos, they were mentioning methods and techniques used for allowing VM instances without a public IP to access public resources. In this case, we are doing the contrary. So we'll create a VPC network, private net in custom mode. Okay, let's go. VPC network, create a VPC network, which will be private net, custom, and then new subnet, specify the following and leave the remaining setting as the defaults. Private net US. Okay, we have private net US, US East 1 as region. Yeah, let's go. And then the IP range will be this one. The rest doesn't mean anything for us. Let's go. Don't enable private Google access yet. Click done, click create. Oh, let's see if it took my subnet settings. Otherwise, we'll just need to go inside the VPC and create again the subnet. It's taking some time. Okay. Okay. So now we okay, to increase the performance. So I generated the keys, the necessary keys. Okay. But now, did the command prompt give change to VM internal? Oh yeah, okay, so I didn't pay attention to this. Okay, now I understand. Before we were in the Cloud Shell VM, now we're in VM internal. Great. To test the external connectivity of VM internal, run the following command. Okay, so now from here we run a double ping to Google. So now this machine could not reach the external internet. Okay. So now we just exit from the SSH connection. Okay. Via managed VPN gateway or Cloud AP tunnel. Cloud AP enable context-aware access to VM via SSH without Bastion hosts. To learn more about this, see the blog post. Okay. Bastion hosts. Let's see what is a Bastion host. In networking, what is a Bastion host? A Bastion host is a secure server specifically designed to act as a gateway between an external network and the internal private network. It's often used in network security to provide controlled access to resources in the private network. Key features of a Bastion host: restricted access, publicly accessible, hardened configuration, single entry point. Okay, example in Cloud GCP. A Bastion host could be a compute engine with an external IP address. Administrators connect to this VM via SSH, and from there, they can access other internal VMs in the VPC that cannot have public IPs. Does the Bastion need to be in the same VPC? No, the Bastion does not necessarily need to be in the same VPC. Okay, it can, I mean, imagine you can use other design to connect to the VPC then. Why with IIP I do not need a Bastion? You don't need a Bastion with AP because AP provides a secure and managed way to control access to resources in your network without requiring a separate publicly accessible gateway like a Bastion host. Key reason IAP replaces a Bastion eliminates public exposure. Okay. AP allows you to access internal resources without exposing them to the public internet. It uses Google managed infrastructure to create a secure authorized tunnel. Identity-based access, IP authenticates users via a Google identity instead of managing access to the network level, blah, 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 okay. And why VPN needs a Bastion? I mean, does GCP VPN gateways need Bastion? No, VPN gateways do not require Bastion either. They are designed to securely connect networks, blah, blah, blah. Okay, well. Task 2, enable private Google access. VM instances that do not have external IP cannot connect, blah, blah, blah. So create a cloud storage bucket. Name, enter a global unique name. I will use the project ID. So we go to cloud storage, to the buckets. We create a new bucket. We give this name to the bucket. In multi-region. Okay, it's already multi-region, US multi-region. Click create. Confirm. Store the name of your bucket in an environment variable. Export my bucket. Okay. So export my bucket, put my bucket name here. So my bucket name will be the project plus dash bucket. Do I need double quotes? Let's see if it takes it automatically. Yeah, it took it. So now echo my bucket. What the fuck? Oh, I'm missing the dollar sign. Fucking dollar sign. Okay, now we have it. Copy an image file into the bucket. So I will first of all copy it. Oh, we have already an SVG image in a cloud training bucket. So I will copy it directly there. Great. Fuck. So this image apparently does not exist. Or let's see if it's publicly available. We can check it. Oh, Jesus. Fuck. Oh, man. Okay. Now what? So I will just upload an image. Let's see if I have any image locally. I think so. I have something for sure. So I have a screenshot. We need an SVG. So I will just download an SVG image from Google. Images. We download this one. Save image as, yeah. No, I want to fucking tools more. Type. Come on, guys. SVG. Let's see, is this an SVG? Savage. Okay, now we have it. So Kiwi, okay, this is it. Upload files, download Kiwi. Okay, Kiwi SVG. Now, man. When uniform bucket level access is enabled. What the fuck is this? Hmm. Man, I did something wrong. So let's delete this, create a new bucket. The new bucket will be, again, my project ID plus hello. Okay. Hmm. So strange. So it's just a name and the multi-region. Okay. Create, enforce, confirm. Okay. And now we have again these buckets. We copy the bucket name, we export my bucket to equal okay. However, let's see if maybe now it works. True. Man, now it worked. I don't know. I cannot find a rationale to this. Let's go anyway. Can access the image from your bucket. So, this bucket is in the US, storage class. Okay, so basically it's an external resource, it's a public resource. So VM internal cannot access it. In Cloud Shell, to try to copy the image from your bucket, run the following command. Okay, okay, now we have it in the file system of this VM on which we are running the Cloud Shell. So now we connect again to our VM internal. Okay, we're connected. Store the name of your bucket in an environment variable. So we have it under this name dash hello. Okay. Verify it with HO, cloud storage, copy. Okay. It will not work because in this case, oh, no, it should work because my bucket Yeah, it should work. This should not work. Okay, can only send traffic with the, okay. Okay. Oh, so now we have to enable the private Google access. So let's go to VPC, click private net, subnet, private net, edit. Okay. VPC. Okay, private net, edit. Private Google access. Okay. So private net, subnets, private net US. Edit. This is on now. Save. Track my progress. Let's go. Okay, now run the following command in Cloud Shell from VM internal to try to copy the VM. Okay. Now it should work. Great. This should work because VM internal subnet has private Google access enabled now. Therefore, as the VM internal has only the internal IP, it will be able to leverage this. Okay, exit also from this one. To view the eligible APIs and services that you can use with private Google access, see supported services. Oh, so it's not all the APIs which can be used in this way. Okay, so task 3, configure a Cloud NAT gateway. Although VM internal can now access certain Google APIs and services without an external IP address, the instance cannot access the internet for updates and patches. Configure a Cloud NAT gateway, which allows VM internal to reach the internet. So try a sudo get update. Okay, so now we'll update the Cloud Shell. It will do it in a second. Okay, then we connect the SSH, the internal VM. Of course, it will fail. Sorry. Okay, so it's not working. As you can see, it's blocking here. Let's go. So now we'll configure a Cloud NAT. So type network services, search for network services product and page section. Network service, click P, network services. Click Cloud NAT. Okay, so network services, Cloud NAT. Get started to configure Cloud NAT gateway. private net, and then you assist one. Cloud for cloud router, select create new router. And then the NAT mapping for the NAT router. So click create now. Click create. Okay. Wait for the gateway status change to running. Okay, already running. Check my progress. Great. Verify the cloud NAT gateway. So again, we get back to our VM internal. Now we can do it. Okay, so now we closed it and we go to task 4. Configure and view logs with Cloud NAT logging. Okay. Cloud NAT logging allows you to log NAT connections and errors. When Cloud NAT logging is enabled, one log entry can be generated for each of the following scenarios. When a network connection is using NAT is created, when a packet is dropped because no port was available for NAT. You can opt to log both kinds of event or just one or other. Create logs are sent to cloud logging. Enable logging, so we go to cloud NAT config, click edit, and then advanced configuration. And for logging, select translation and errors. Save. Okay, now logging, cloud logging. So now you have set up cloud logging for NAT config gateway. Let's find out where you can view your logs. Click on NAT config to expose its details and click viewing the logs. Explorer. You will see that there aren't any logs yet. It's because filter gateway. Keep this tab open. Okay, so now as a reminder, cloud generated following sequences. When a network connection using is created, when a packet drops you. Okay, let's connect. Okay, so let's connect again. SSH into the VM internal. Try to synchronize. Okay, again. Turn view logs or to your log tab explorer. So end lab because we already are sure that here will appear some logs and we can be able to explore it. Hello, let's see if it still exists and we can see the logs. Great, so we finished all this lab. Let's see if here appeared something. I think we already lost all the machines and the underlying infrastructure. But yeah, in the end, we will see some logs for a created connection or for some error. Therefore, let's continue. And let's see the lab review. And then we will finish doing the quiz about the virtual networks.
In this lab, you created an instance with no external IP address and access it using Cloud IAP. You then enabled private Google access and configured a NAT gateway and verified that VM internal can. Once it's up and running, we're going to add.
Here, someone is repeating the same exercise.
Botnet, but not in botnet. In other words, what that means is that hosts outside of your VPC network can only respond to connections initiated by your instances. They can to allow other.
Okay, so the details about the logs, maybe
new connections to your instances
here.
via the NAT. So keep that in mind. The other thing is in this lab, where you connect to access using VMs using IP tunneling, you need to grab and go to Cloud IP and just give people those roles. That's the end of the lab.
Okay. Perfect. In Google Cloud, what is the minimum number of IP addresses that a VM instance needs? One, only an internal IP address. What are 3 types of networks offered in Google Cloud? Yeah. What is the benefit of applying firewall rules by tag rather than by address? Applying firewall rules by tag rather than by addresses. So tag help organization track firewalls billing. Tagging is network traffic help with network sniffing. Control which ephemeral IP addresses VM will receive. When a VM is created with a matching tag, the firewall rules apply irrespective of the IP addresses assigned. Scalable. Okay, we finished this.
In this module, I gave you an overview of Google's virtual private cloud. We looked at the different objects within VPC, like projects, networks, IP addresses, routes, and firewall rules. I also provided a brief overview of how your network design choices can affect billing. Then you applied the different concepts that we covered in a thorough lab. Next, we looked at common network designs, and you got to implement private Google Access and Cloud NAT in a lab. Now that you have a solid understanding of how GCP has implemented networking, let's move on to learn more about other services. Next up is Compute Engine, which offers scalable, high-performance virtual machines.
Great. So for this video, we already recorded 1 hour.
In this module, we cover virtual machine instances or VMs.
Therefore,
VMs are the most...
we stop here, and I will continue with virtual machines in the next video. Therefore, I will see you there. I hope this is useful in some way.